Section 10.2, question E23. We have this theory about dissolving salt in water and having a lower freezing point than the 32 degrees Fahrenheit we would get for pure water. Notice, this is key, our alternative hypothesis is that the freezing point will be lower, not will be different from 32 degrees. So this is telling us that a one-sided test is what we want to conduct. If it had said the theory believes that 32 degrees Fahrenheit is not the correct freezing point for salt water, but we're not really sure if it's above that or below that, that would be a two-sided test. So we're just looking at the direction of our alternative hypothesis. And here we see one-sided. What is the sample mean and the population mean for the problem? So the sample mean would be the mean freezing point of these 10 bowls. We're going to repeat this thing 10 times. So these 10 bowls, check the freezing point of these 10 trials, and then take the average of those. So that's the sample mean. The population mean is the true freezing point. This hypothetical, if we were to do every time that we would put these bowls of salt water in a freezer, all the possible data points we would get and average them, that would be a population mean. And the null and alternative hypothesis, the null is just nothing's going on, the current claim, anything that we're testing against. And here in this case, we're going to say the salt water freezing point is also 32 degrees Fahrenheit. Now that doesn't sound like a very good hypothesis to have. The point of the null hypothesis is not to say what you think is going to happen. Even though it has the word hypothesis in it, null hypothesis is what happens if there really is no effect, or there's nothing going on, or there's nothing different from the standard. So if salt water really doesn't change the boiling freezing point, then it should be the same as pure water. So that's why we have the null hypothesis is 32 degrees population mean. Our alternative, remember we're doing a one-sided test, so it should either be less than or greater than 32. And if we look here, we're saying that the freezing point will be lower for salt water. So we would expect our alternative hypothesis to be less than 32 degrees Fahrenheit. So what would we do next? We would get the sample mean, standard deviation, calculate a t-statistic, p-value, and we would look if that p-value is less than the 0.05 cutoff, which is standard here. And if it was, we would reject the null and say, hey, we do probably have a lower freezing point. If, on the other hand, our p-value was above 0.05 or whatever our cutoff is, and then we would say, it may or may not be lower than 32, but we don't have enough evidence, so we're going to stick with our null hypothesis for now.